Okay. So I guess question one is, so you mentioned that you're using a Perfect Flight Stratologger. Do you know if it's an SL100 or an SLCF? I mean, it's not a huge difference, but just wondering. Yeah.
Billy, I'm gonna let you take this.
Yeah, it's a high alt 45K. Is that?
So it's one of the. Yes. Oh, so it's one of the really old ones.
Yeah, no, it's old. Yeah.
Yeah.
Just the job done.
Yeah. Do you have to worry about? I guess follow-up question to that, because I don't think I've ever actually seen one of those altimeters. I haven't seen one of those altimeters in years. Is that one where you have to like set up mock delays?
Yeah, so it has 4 jumpers.
Okay.
For all the programming, so there's 2 jumpers for the drogue delay and then 2 jumpers for the altitude.
Okay. Yeah. So did you guys? So how did you guys go about setting up the mock delay? If I remember correctly, you guys didn't quite get transonic. So I guess it probably doesn't really matter.
No, we did not go transonic.
Okay, so yeah, so you didn't have to worry about mock delay on that. Something to keep in mind though is that you you might want to look into getting, if you can find one, an SLCF or something similar.
For future rockets, we're planning to use mock hardened electronics, so we don't need to worry about delays or anything like that.
Yeah, exactly. Yeah, you might be worth retiring those altimeters, because it's getting to the point where they're probably about as old as you guys.
They're good. They worked for a long time. But yeah.
Yeah.
Last year we'll probably use it on an IREC rocket.
Yeah. So I see that you guys ended up also using lots of carbon fiber. So question one is, so you guys have a filament winder, lucky you guys, that you use for your airframe tubing.
Yes.
Why the choice to do a hand layup for the nose cone, as opposed to filament winding that as well?
So we wanted to do a multitude of different composite manufacturing methods. The body tubes for winding, that was a big learning curve for us. We'd never done anything like that. It was gifted to us. We didn't buy it, and they gave us no instructions on how to use it, pretty much. So we took like a first semester approach of really learning how to use that machine. And at the end, we got some good body tubes, but it was still quite complex to do that. And we weren't able to fully use the machine in its 4th axis capabilities. So we were able to get body tubes, but not use it to its full potential. And the nose cones, we wanted to be able to make them out of molds and the boat tail. And so that's why we wanted to, instead of using the X winder, which could possibly do it, we decided to just do a mold instead.
Yeah. Okay. Yeah. Just wondering. Yeah.
For 4th axes are pretty challenging, and so
Yeah.
getting that contour you can do in like a professional environment when you have a
yeah.
much more rigid frame. But getting the tapered nose cone to the low diameter is really challenging without having the fiber from slipping. So we played around with some conical shapes or spherical shapes with the 4th axes, but it was really challenging to be reliable with.
Okay. Yeah. Makes sense. Okay. So the next question is, I forget if I must have seen it somewhere. What did you guys do in terms of trying to get, so for RF transparency, you for your transmitters, did you use like a fiberglass section somewhere for RF transparency? Yeah.
This will be of two parts. No, we didn't actually. We stuck an antenna outside the airframe and made a shroud covering that made it as close to the airframe body tube as possible, providing this little drag as possible. And we were able to get lock just using that.
Oh, right. Yeah, I did. I think I did notice that somewhere in here. And I thought that that was pretty clever. Yeah. So what did you do in terms of I'm going to attempt to step in for our missing RF engineer. So what did you do in terms of testing of that system to make sure that you that you were able to maintain lock? Did you do any testing with like varying the orientation of both the rocket and the ground station?
Yes, I can
yeah.
let Will or Billy take this question.
Sure, yeah, I can take this one. We did a lot of field testing with it since we had the tubes for quite a while. So we just kind of set it up exactly like it would be in the rocket. We did change around the orientation a bit, between 90 and 45, and then flip it around for when it's in free fall after apogee. And we had fine range the whole time. We never really had any problems with any range we would be dealing with at our test field. So yeah, we just did it all experimentally.
Okay, and as part of that, I assume you did make sure that, because if you've got the antenna on the outside, if it's on the opposite side of the rocket from your ground station, you're still going to have that. You're still going to have a fair amount of RF blocking there. So you didn't have any problems with that,
No, we didn't.
rotating the airframe around?
No, we just used 2 dipoles, so the pattern worked pretty well for us.
Yeah. Okay. And then I guess I will go with my standard question about powering all of your avionics. So I believe I recall seeing that you guys use 9 volts.
Yeah.
Yeah. So what did you guys do in did you use 9 volts or
No, we
did
did
you
not
use?
use-
Oh,
We used
okay.
2 cell lipos.
Oh, right. Yep. Yeah, I see those. Yeah, lipos. So yeah, so you don't have to worry about anything with those failing. Lucky you
No.
guys. Yeah.
Yeah.
And then what did you use for switches?
We just used COTS key switches that we've
Okay.
had quite a while.
Yeah.
Just 2, 1 per deployment computer.
Yep. Sounds good. Simple, gets the job done, works.
Yep.
And then let's see. What do you guys see? What do you guys get in terms of pad life for your various electronics on those 2S lipos?
We were getting something like 7 hours. We didn't do that experimentally because we didn't wait around for 7 hours.
Yeah.
And then the tracker gets 10 hours, and our student research one was around 8 hours.
Okay. Yeah. Was the 7 hours was for both the stratologger and the egg timer, or was that just for the egg timer?
Yeah, little variation, but yeah, around 7.
Okay. Yeah. I know that I guess those old stratologgers must consume a lot more power than the new ones. Because I know that the new ones basically the new ones, I remember doing some calculations a while ago and realizing that even on just like a 9 volt, they can last for like 2 weeks.
Yeah.
Which is just kind of absurd.
Right, they met our requirements, so we were fine with it.
Yeah. And then I guess the other question I have for you guys is I think you guys missed having your like testing appendix in your documentation here. So can you quickly sort of describe the tests that you did and what the results of all of those were?
Sure. So initially for the body tubes, FEA analysis is kind of hard when you're winding your own body tubes, though. It's like just
Yeah,
you
of
said,
course.
experimentally, we did it just adding weight to the tubes. We never broke them, so it's like I was like, all right, we can't break it. And then we did a deployment testing. That was the most important thing we thought of for testing wise, and our tracking was also incredibly important, like Will already had talked about. We had done some FEA analysis on the motor mount tube, and that wasn't in there. Our student who had done that, he's graduated, and I couldn't get his data that he'd done before, and I couldn't add that in.
Okay. Yeah.
But that was most of the testing that we did,
Okay.
and besides the launch.
Oh,
yeah.
Yep. Yeah. So you did. Yeah. You guys did a flight test. Yeah. So how did any anomalies on that, or was it all working for that?
That was a perfect flight. Came down exactly what we predicted. We're 100 feet off of my predicted altitude via our simulations. It was pretty great.
That's pretty good. 100 feet off at 10K.
Yeah.
That's impressive. So yeah. So I think in that
One of the
case,
important things that we did to achieve that accurate simulation was a very comprehensive review of the masses and location throughout the rocket before we launched, as well as simulating the launch before with the conditions given. So that helped us get a little bit more accurate than just catting something up and then sending it from there.
Yep, that makes sense. All right. I don't think I have anything more for you guys. So unless you have anything that you want to ask me or that you think would be important to mention, I think that's probably it.
Yeah, this was RIT's first time creating completely custom body tubes, aerostructure really. We'd never done anything much like this. And it was a great learning experience, but I think it came out really great. And hopefully the judges think so also.
Yeah, no, I think the of the teams that I've looked at least, you guys are the only ones with a filament winder, and I'm jealous.
Jasper, where are you from?
I'm from the DC area.
Gotcha.
Oh. Hey, by any chance, do you know Michael N. Barnett?
I do not know.
Okay, that'd be strange if you did, but then it would be second cousins.
Huh. All right. Yeah. So I think, unless you guys have anything else, time for Cal State. Nice job, guys.